What if I told you that the intense physical ache of losing someone isn't actually, well, an emotion at all?
Right, it's something entirely different.
Yeah, like what if the pain you feel is literally your brain's internal GPS system malfunctioning, just desperately trying to route you to a destination that no longer exists? Welcome everyone to vpod.ai. I'm your host, Mike, and sitting across from me today is our expert guest, Susan.
Hi, everyone. It really is a profound topic we're tackling today, and I'm just so glad to be here to unpack the science behind it all.
Before we go any further, I have a quick message. You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit vpod.ai to get started today.
So when we talk about healing from a monumental loss, the cultural conversation almost exclusively centers around the heart.
Right,
We
yeah.
talk about needing a shoulder to cry on or waiting for time to heal all wounds. We treat grief as this purely ethereal, emotional cloud that you just have to sit in until it eventually passes.
Which is why we're taking a completely different approach today.
Mhm.
We are looking strictly under the hood of the human brain to uncover the biological and psychological reality of how you actually heal from loss.
Exactly.
Because grief isn't just an emotional phase. It is a massive physiological reconstruction project happening right inside your nervous system.
It really is. And to understand that machinery, you kind of have to unlearn a few outdated concepts that have just been accepted as universal truths.
Right.
The most prominent one being the famous 5 stages of grief.
Oh, sure. Denial, anger, bargaining, depression, and acceptance.
Yes, exactly.
That framework was pioneered by the psychologist Elizabeth Kubler-Ross decades ago, and it's basically become this cultural gospel. You lose someone, and the expectation is that you just walk up those 5 steps like a neatly organized staircase.
Right. But modern neuroimaging reveals a much messier, far more nuanced reality. While those stages definitely resonate with the lived experience of a lot of people, they simply aren't a strict linear roadmap. Yeah, researchers have utilized functional MRI scans, which, measure blood flow to track real-time brain activity, to demonstrate that grief and depression, for example, are entirely distinct processes neurologically.
Which is wild because from the outside, the behavioral symptoms look almost identical.
Completely.
I mean, you lose your appetite, your sleep architecture completely falls apart, you might find yourself just paralyzed by sadness in the middle of the day. It perfectly mimics clinical depression.
It does. Under a brain scanner, though, depression looks like a global dimming of the brain's motivational centers. It's a state of profound physiological apathy.
Okay, so just everything shutting down.
Right. But grief, conversely, lights up the specific neural circuits associated with craving, pursuit, and intense motivation. Your brain is highly active. It is actively searching for the person who is missing.
Which brings us to how the brain actually knows who it's searching for.
Yeah.
I mean, if my brain is actively searching, it implies it possesses some sort of map and thinks the person is just physically misplaced.
Makes sense.
And that mapping system relies on 3 incredibly specific dimensions to categorize every relationship you have, which are space, time, and closeness.
Yeah, so space is straightforward, like, where is this person physically located right now? Are they sitting right next to you, or are they 1,000 miles away?
Right.
Time is the internal calculus of when you expect to interact with them next, or how long it's been since you last saw them. And then closeness is the actual depth of the emotional attachment.
It sounds almost too mechanical, to say that profound human love is plotted on an internal coordinate grid.
It does sound a bit cold, but there is a remarkable experiment that physically demonstrates this. Researchers actually put subjects into a functional MRI scanner without making any assumptions about what parts of the brain would activate.
Oh, wow.
They just ran 3 completely different visual and auditory tests. First, they showed them pictures of physical spaces, like a beach or a parking lot, featuring bowling balls placed at varying distances from each other.
Okay, so they were isolating the variable of physical space.
Exactly. Then, to test the dimension of time, they had the subjects listen to a series of tones, and they systematically altered the gaps of silence between those tones.
Like sometimes rapid, sometimes drawn out with long pauses.
You got it. And finally, they tested emotional distance. They showed the subjects photographs of people, ranging from extreme close-ups to wide shots taken from a distance.
Right.
But more importantly, they varied the emotional proximity. So they would show a picture of the subject's sister, followed by a stranger on the street, then maybe a distant celebrity, and then a neighbor.
And the crazy part is, changes in all 3 of these wildly different conditions Like the bowling balls in space, the tones in time, and the emotional distance of faces, they all activated the exact same localized brain area.
Yes, the inferior parietal lobule.
So, if I'm understanding this correctly,
Eh.
does this mean the brain essentially operates like a social GPS system? But instead of just mapping streets, it's literally mapping out exactly how many hours or miles it will take to reach someone you love.
That is the perfect analogy. It operates as a hyper-accurate social GPS. It doesn't just, store the feeling of love in some abstract emotional center.
Wow.
It braids that emotional closeness intimately together with the physical GPS coordinates of where that person is and the temporal coordinates of when you'll see them next.
So because of that deeply braided map,
Yeah.
you spend your entire life with someone building a massive catalog of what we call episodic memories.
Right.
You consciously and subconsciously record their routines. You know the specific cadence of their footsteps. You know exactly what time they usually walk through the front door after work. And your nervous system uses that catalog to constantly generate predictions about reality.
Exactly. It's a prediction engine.
Yeah.
It expects them to be sitting in their usual chair at the dinner table. It expects them to pick up the phone on the second ring because they always have.
Yeah.
And when a loss occurs, those neural predictions don't just magically shut
They
down.
just keep firing.
Yes, the brain continues to generate reverberatory activity. The neural circuits are still firing, putting your body into an action state of seeking. Your dopaminergic pathways are expecting the reward of seeing that person, and when they aren't there, the system essentially shorts out.
It sounds to me like a massive error message in the brain's prediction software. So
Yeah.
the emotional pain we feel is literally our brain aggressively searching for a signal from a server that is no longer online.
That's exactly what it is. And
Yeah.
because that server is offline, your brain is forced into the incredibly difficult process of uncoupling and unbraiding the emotional attachment from those dimensions of space and time.
Wow.
That is the biological definition of grief. You literally have to update the map.
I mean, that concept can sound terrifying for anyone actively mourning. The immediate fear is that if you uncouple your loved one from space and time, you are actively dismantling your attachment to
Yeah.
them. And no one wants to intentionally erase the bond they have with someone they've lost.
Absolutely. It is a common and completely valid fear, but the distinction here is vital. You are not erasing the emotional depth or the love.
Okay, good.
That remains perfectly intact. What you are doing is updating the GPS coordinates to reflect reality. You are training your nervous system to understand that the intense emotional closeness remains, but the expectation of them walking into the physical room at a specific hour must be dissolved.
So that internal friction explains the yearning, but you see massive variations in how people handle that friction, right?
Oh, absolutely.
Like two people can lose the exact same family member, and one gradually adapts to the new map while the other remains paralyzed, seemingly trapped in this endless loop of reaching for a past that no longer exists.
Yeah, and to understand why that happens, we have to look at the neurochemistry of yearning, specifically a peptide hormone called oxytocin.
Right.
It is heavily involved in pair bonding, parent-child attachment, and basically the chemical reinforcement of relationships.
Some incredibly revealing research on this comes from the animal kingdom, specifically looking at the prairie vole.
Yes, the prairie voles are fascinating.
Because what makes the prairie vole unique in neuroscience is that certain populations are strictly monogamous-like. They mate and bond for life, while other populations of the exact same species are entirely non-monogamous.
Right, so researchers separated a bonded pair of monogamous prairie voles with a physical barrier. The monogamous voles exerted massive amounts of energy physically fighting and striving to get past that barrier to reunite with their mate.
Just relentless.
Exactly. But when the exact same barrier experiment was run with non-monogamous voles, they simply didn't put in the effort. They quickly abandoned the pursuit.
And the biological driver behind that relentless pursuit in the monogamous voles comes down to the density of their oxytocin receptors.
Yes.
They possess a significantly higher concentration of these receptors in a specific region of the brain called the nucleus accumbens. And that is the brain's primary motivation and craving center. It's the core of the reward pathway.
So their profound feeling of attachment is directly hot-wired into their biological motivation to pursue. And when we map this onto human neurobiology, we see the identical pattern.
Really?
Yeah. Individuals who experience prolonged, complicated grief, which is characterized by unending yearning and agonizing counterfactual thinking, the constant loop of what ifs, they often have heightened oxytocin receptors in those exact pursuit and craving centers of the brain.
Wow. So it's like having a sports car with a massive engine, but when grease hits, that oxytocin engine is just spinning its wheels in the mud, creating all these endless "what if I had done things differently" scenarios.
That is a great way to picture it. Experiencing that doesn't mean you loved the person more than someone who processes the loss faster. It is often just a reflection of your unique neurochemistry linking attachment intimately to active pursuit. You literally have a biological craving to solve the problem of their absence.
Okay, but it's one thing to understand that our oxytocin receptors are firing blindly. You can't just think your way out of a profound chemical craving.
No, you really can't.
You have to physically intervene to help your mind rewrite this outdated GPS map. And that brings us to how the body actually communicates with the brain to facilitate healing.
Right. We have to establish the physical foundation of healing. There is a fascinating study examining emotional disclosure, specifically having people process grief by writing letters to the person they lost, or writing extensively about their deepest memories of the loss.
Now, the intuitive assumption is that journaling and expressing those feelings would be universally therapeutic for everyone, right?
You would think so, but the data showed it only provided significant relief for a very specific subset of individuals, those who naturally possessed high vagal tone.
Okay, vagal tone is a term thrown around constantly in wellness circles, but in this specific context of grief, what is it actually doing mechanically to the nervous system?
So the vagus nerve is the massive communication superhighway connecting your brain to your internal organs. Vagal tone refers to your physiological ability to modulate your own nervous system, primarily through a mechanical process called respiratory sinus arrhythmia.
Okay, break that down for us.
Sure. When you engage in a prolonged, slow exhale, the physical movement of your diaphragm interacts with your thoracic cavity. This pressure change actually signals the vagus nerve to secrete acetylcholine, which physically forces your heart rate to slow down.
Oh, wow. So individuals with high vagal tone are simply people whose bodies are highly efficient at breaking their own panic response through their breathing.
Exactly. And because their bodies weren't flooding with adrenaline, they could safely access these somatic, physical feelings of attachment while writing. They could mentally hold the memory without their nervous system interpreting it as a biological threat.
That is wild. The physical state of the body dictates the brain's ability to process the emotional memory.
It absolutely does. And that physiological scaffolding is also heavily dependent on your circadian hormones, most notably cortisol. Cortisol is vital for your daily rhythm of waking up and maintaining alertness. In a healthy cycle, it peaks right after you wake up and plummets to its lowest levels by 4 p.m. and 9 p.m., which allows your body to downregulate into sleep.
But in individuals suffering from complicated grief, where the brain refuses to update the internal map, researchers found their cortisol rhythms were completely inverted or elevated.
Yes.
They had abnormally high cortisol levels at 4 p.m. and 9 p.m. Their nervous systems were chemically locked into a state of high alert well into the night.
And the biological mechanism to correct that inverted rhythm is entirely dependent on light viewing. Getting bright, natural sunlight in your eyes shortly after waking up triggers melanopsin cells in your retina.
Right.
Those cells send a direct electrical signal to the suprachiasmatic nucleus in your hypothalamus, which is basically the master clock of your brain. That signal guarantees your morning cortisol spike, which acts as a biological timer, ensuring that cortisol will properly vacate your system 12 to 14 hours later.
Okay, so for anyone listening, getting morning sunlight and practicing those long exhales isn't just about feeling zen. It's literally setting up the physiological scaffolding the brain requires to safely rewrite its internal GPS map overnight.
That is perfectly stated. If your evening cortisol remains high, it physically blocks your brain from entering delta wave deep sleep. And deep sleep is the non-negotiable requirement for neuroplasticity.
The actual rewiring.
Right. You can engage in all the emotional processing, therapy, and journaling you want during your waking hours. But the actual physical rewiring of the synapses, the permanent updating of your brain's space and time map, only occurs while you are unconscious in deep sleep or engaging in practices like non-sleep deep rest.
So the cognitive effort you exert during the day simply flags the neural circuits that need to be changed, but the actual construction crew that goes in and reroutes the wiring only clocks in when you are deeply asleep.
Exactly.
Without that sleep, the daily cognitive work doesn't get saved to the hard drive.
Exactly right. So with that physiological foundation secure sunlight, resetting the cortisol, breath work managing the vagal tone, and sleep enabling the neuroplasticity, we can finally look at the active cognitive work required during the day.
And this brings us to a highly specific, science-backed tool known as rational grieving.
Hmm.
It involves deliberately blocking out a period of time, anywhere from 5 to 45 minutes, to consciously lean in and deeply feel the attachment you have for the person or animal you lost.
Yeah, and the natural human instinct is to flinch away from that pain, to constantly distract ourselves by staying busy or to numb the yearning, but chronic distraction completely prevents the brain's map from updating.
Right, you're just avoiding it.
Exactly. During rational grieving, you sit down and you fiercely hold on to the intensity of the love. You allow yourself to feel the full weight of that bond. But there is a strict biological rule for this practice.
And it's a tough one. You must aggressively prevent any counterfactual thinking. No what-ifs. No, if only I had recognized the symptoms sooner. You have to rationally ground yourself in the absolute reality that they no longer exist in the same space and time.
Yes,
But why is that specific rule so critical on a neurological level?
because counterfactual thoughts are the fuel for the nucleus accumbens. When you indulge in what-ifs, you are feeding your brain a microscopic dose of false hope.
Oh, wow.
Yeah, you are tricking your neurochemistry into believing that there is still a puzzle to be solved, which triggers that oxytocin-driven seeking behavior. By forcefully denying the what-if, you starve that craving center.
That is so counterintuitive, though.
It really is.
I mean, human instinct is usually to look away from pain, but the science is telling us we actually have to look directly at the love we had, purely, without trying to rewrite the past in our heads.
Right. You force your nervous system to accept that the physical location is permanently gone, while simultaneously signaling that the attachment is still profoundly real.
So you're holding the immense love in one hand and the harsh reality of their physical absence in the other, and forcing your brain to synthesize those two conflicting truths. You are breaking the association between emotional intimacy and physical proximity.
It is exhausting, rigorous cognitive work, but it is the biological mechanism that forces the unbraiding process. It's how you ensure that your memories of them remain a permanent source of richness and grounding in your life, rather than a trigger for severe physiological disorientation.
Bringing all of this together, it completely shifts how we view the healing process. Grief is not a passive waiting game. It is an active neurobiological reorganization.
Absolutely.
Your brain relies on an incredibly intricate map of space, time, and closeness to locate the people you love. When they are gone, that intense, breathless yearning is simply your internal GPS aggressively trying to route you to a destination that has vanished.
And by consciously supporting your physical body, like regulating your master clock with morning sunlight, controlling your panic response through long exhales, and safeguarding your deep sleep, you provide your brain with the biological resources it desperately needs to safely open up that map.
And through deliberate practices like rational grieving, you take control of the rewiring process. You starve the endless craving of the what-ifs. You update the coordinates to accept their physical absence. And you keep your most cherished attachments beautifully, permanently intact.
You are never dismantling the bond. You are simply changing how that profound love is mapped within your mind.
It is a remarkable testament to the adaptability of the human brain. And it leaves me with a final thought for you to mull over.
Oh.
If our brains dedicate so much raw metabolic energy, so much intricate neural architecture to precisely mapping the physical space, the exact timing, and the profound emotional depth of everyone we care about right now, what does that invisible map look like right now for the people you haven't even met yet, who will one day become your deepest attachments?
That is a brilliant perspective to carry forward.
Thank you for joining us for our discussion today, and until next time, keep exploring.